All right, here's a lesson on rational expressions. So first, what is a rational and an expression, and what are we going to do with them? So a rational, mathematically speaking, it connects us to a fraction. Now, I want to know if you remember this from the rational zero theorem, where we want P over Q. A rational, the word I really want you to think of is the word fraction. And if I connect rational correctly to what we've been doing, a rational is the quotient of a polynomial and another polynomial. So when I have a polynomial divided by a polynomial, that is what a rational is. So the quotient of two polynomials is a rational. So when I think of rational, I think fraction, I think dividing. And now the steps are, how do I simplify that? And we're going to talk about multiplying and dividing too. So when I simplify it, it's kind of similar to simplifying any fraction when we talk about a common factor and simplifying it down. When it's algebra, step one is going to be the ability to factor. And then step two is to remove any common factor in the numerator and denominator. And then what's left over is your answer. So we're going to do examples like that. So step one is to factor, and then step one is to remove. Step two is to remove any common factor in the numerator and denominator. So let's look at some examples of what you're going to do for your homework. So here's an example in terms of it. So we'll start with a simple example. That is what's called a rational. Both the numerator and denominator are polynomials. To simplify this, we're going to factor what we can. So I'm going to factor out a 5. The denominator is prime. There's nothing to factor. And then you remove a common factor that you see both in the numerator and denominator. So we can remove it by dividing, and then we have our answer. Here's another example. This is a rational, and I want to simplify it. Step one is to factor it. So what two numbers multiply to -6 and add to 1? Look at the denominator. What two numbers multiply to -12 and add to -1? And then look, is there a common factor that can be removed? So divide out the common factor, and then what's left in the numerator, what's left in the denominator, that's your answer. Now, we can also do this with multiplying. We can do different letters too. So here we are multiplying two rationals together. Step one is still to factor. So is there anything factorable here? 3a is prime. A plus 2 is prime. A squared, I'm looking at the quadratic. Can I factor this? This is called the difference of squares. And now you look and see what's removable. So a plus 2 is removable. A is removable. And then 3 goes into 6 twice. So do all the removing, and what you're left with in the numerator and denominator, and you have your answer. Let's look at another example of multiplying. This. Do that right? 2 and 1. I meant to do 2. All right, so write that down, and now we're going to practice simplifying this rational. So step 1 is to factor it. So if you need to press pause, do, and then press play. So what two numbers multiply to 1 and add to 2? And I'm not going to write it as squared because it'll be easier to simplify to put them in this form instead. What two numbers multiply to 2 and add to 3? X squared subtract 9 is called a difference of squares. Here, in the bottom of the fraction, what two numbers multiply to 12 and add to -7? And now simplify this. So anything in the numerator can remove anything in the denominator, even if it's not the same fraction. So x plus 1, they remove. X subtract 3, they remove. And there's nothing else that removes. So we're just going to put them beside each other, and there's our answer. So there's our numerator, and then our denominator. Now, the last thing we're going to do is we're going to focus on dividing. So if I'm dividing rationals, let me set this up. So what's the key to dividing is to change this to multiplying first, and then it's just like what we did before. So if I change it to multiplying, do you remember the rule to dividing fractions? Is you change it to multiplying by doing the reciprocal of this, which is called the dividend, or the divisor. So the reciprocal, there we go. At this step, this is exactly now like multiplying. So factor what you can. P plus 7, P take away 6 is prime. What two numbers multiply to 42 and add to -13? The denominator is a difference of squares. That's P plus 7 and P subtract 7. And now, anything in the numerator can remove anything in the denominator. P plus 7, P take away 6, P take away 7. Now, everything removed. Everything. So, the answer is not 0. So with everything removed, what number is left over when you remove something? And the answer is 1. So when I do the math, 1 is left over when everything is removed, and the answer is not 0. Let's try one more of dividing, and then that's the lesson for today. Switch up my letters. All right, so write that down. Can you simplify this with me? So step 1 is, let's change that to multiplying. And how do I change it to multiplying? Is by doing the reciprocal. So we're going to flip. This is what's called the divisor. We're going to flip that. Now, we're going to factor what we can. So on the right side, in the numerator, what two numbers multiply to 18 and add to -9? Did I do that right? No, this should be a 14. Can you change that to 14? I was doing it in my head. So what two numbers multiply to 9, or multiply to 14 and add to 9? This is what I wanted. Negative 2 and negative 7. I got there. And then the denominator, take out a common factor. And now anything in the numerator can simplify with anything in the denominator. So do you see anything that simplifies here? So m subtract 7, that simplifies. 3 goes into 9 3 times. And now what's left? We have m subtract 2, and then in the denominator we have a 3m and m subtract 1. So don't forget about that m right there. So 3m, m subtract 1, and that's prime now, and you've simplified it. All right, there's your lesson on simplifying rationals. Simplifying it, multiplying, and dividing. Mr. G Math, over and out. Till next time.